Okay, in this chapter, we are going to talk about cleaners or hydrocyclones. Excuse me for a second. Okay. There are many different type of cleaners available in the market. It's called forward cleaners for removing high density contaminants, reverse cleaners, core bleed cleaners to remove both high and low density contaminants, Throughflow cleaners for low density contaminants, and then we have Gyro cleaners for removing low density contaminants. In general, the important parameters used in separating contaminants from the pulp in cleaners is based on density, size and shape of the particles, but most important is the density. Temperature also plays an important role as it affects the viscosity of the water. Here is an example of specific gravity of some of the contaminants we encounter in paper recycling. Metal is upwards of 2, sand is between 1.8 and 2.2, so on down the line. Filler stickies can be anywhere from 0.9 to 1.1. Wax, styrofoam, plastic is between 0.9 and 1.1. This particular picture shows the basic operation of hydrocyclone. So hydrocyclone is constructed such that we have a cylindrical section followed by a conical section. Fiber water contaminant mixture enters tangentially at the top of the cylindrical section, and it swirls around, generating centrifugal force which throws out high density material towards the wall of the cyclone, and they are transported downward. Due to the size of the underflow tip, all the material from the feed cannot go out through this lower tip, so the remaining material swirls back up and finds its way out through the overflow tube. So basically, we have a one stream feed stream entering the hydrocyclone tangentially on the top of the cylindrical section, and we have underflow and we have overflow stream. So high density material which has been thrown out will come out from the underflow tip, and low density material will go through the overflow tip. So here we are trying to remove nuts and bolts and paper clips, sand through the underflow, and low density material, plastic, styrofoam, stickies will come out through the overflow. So basic principle of separation is somewhat in hydrocyclone. Separation in hydrocyclone is similar to sedimentation, where the Stokes Law is widely used. Stokes Law basically says that the terminal velocity of a particle falling down in the water under the action of gravitational force depends on the size of the particle, square of the size of the particle, where d is the particle diameter. Assuming that the particle is sphere, this law will apply, provided the particle is relatively small and not going very fast. Delta rho is the density difference between the particle and the water. G is the gravitational force, and mu is the viscosity of the water. The reason for giving this law is that we are interested in increasing the settling velocity or the sedimentation velocity or the terminal velocity of this particle. And we want to see how we can do that by increasing the particle diameter, density difference, gravitational force, or the viscosity. To give some idea of how this velocity affects the particle settling rate, let's take an example of particle with density of 1.3, so that the density difference between the particle and the water is about 0.3. Gravitational force natural is 980 centimeter per second square, and the viscosity of water at room temperature. The particle is 100 micron in diameter. It will take about 30 minutes for it to travel 10 feet or 30 centimeter. The particle size decreases by a factor of 10. The time it will take to travel the same distance will increase by a factor of 100, or it will take now 53 hours. 1 micron particle will take 220 days to travel 10 feet under the action of gravitational force. So we can see here that particle of 10 micron or smaller size will be very, very difficult to remove by just sedimentation. So question is, what alternatives are available to increase the sedimentation velocity? So we can increase the diameter of the particle by, for example, some form of agglomeration, or we can densify the particle. We can increase the value of G by applying the centrifugal force, which is what we are trying to do in hydrocyclone, is increasing the value of the G. Or we can decrease the value of viscosity by, for example, raising the temperature. We can increase the size of the particle by agglomeration, which is what we try to do in sedimentation and dissolved air flotation clarifier. So here is an example of various types of forward cleaners which are used to remove high density material. Forward cleaners are classified as high density, medium density, or fine forward cleaner based on the diameter of the cylindrical section. Greater than 10 inch or 25 centimeter we call it high density. 20 to 65 centimeter called medium density, and 7.5 centimeter to 20 centimeter we call fine forward cleaner. Different size cleaners can operate at different consistency. Smaller the diameter, lower the consistency of operation. Different size cleaners are used to remove different size contaminants. Larger cleaner for removing large size contaminants, glass, bolts, staples, as opposed to small sized cleaner used to remove small size contaminants. Here is an example of high density cleaners with double valve operation. So in this particular case, fiber water contaminant mixture enters tangentially at the cylindrical section, swirls around, and high density material is collected in this chamber. Top valve is open and the bottom valve is closed. The remaining material swirls back up and finds its way through the overflow tube, and that is accept. High density material is collected here, and periodically you close the top valve, open the bottom valve, empty the chamber, and right away close the bottom valve, open the top valve, and collect the contaminants in this chamber. So this process continues, and we try to remove high density materials like this, paper clips, staples, metal, and so on. Here is an example of reverse hydrocyclone, where we are interested in removing low density contaminants like wax and plastic. So in this particular case, we take the same hydrocyclone, but now increase the diameter of the underflow and reduce the diameter of the overflow tube. And when fiber water contaminant mixture comes in, you get relatively clean fibers, and low density materials are migrating toward the center. They are removed through the overflow tube. In another example of the reverse cleaner is the so-called Throughflow Cleaner, where we are again interested in removing low density contaminants. So in this particular case, we don't have any overflow tube, So all the flow goes down towards the conical end, and low density material is migrating toward the center, whereas high density material and the fibers are going toward the wall. So fibers are collected from the periphery, comes out as accept, and low density material migrating toward the center comes out through the central tube as the rejects. Advantage of Throughflow cleaner over the reverse cleaner, which we saw in the previous slide, is that the volume of the reject flow is relatively low. So your secondary stage is very small compared to that in the reverse cleaner. Core bleed cleaner is where we try to remove high density contaminants as well as low density contaminants in a single unit. So here we have the feed swirling around, and high density material is removed through the underflow. The remaining pulp swirls back up, low density material concentrating near the center removed through this core, and the accepts going through the annular tube here is removed, and that is your clean fiber devoid of low density and high density contaminants. The last type of cleaner is gyro cleaner, where the whole cylinder body is rotating at a high speed. Fiber water contaminant mixture comes in, swirls around, and low density material is migrating toward the center and is removed through the central tube as rejects. The remaining material comes out through the annular space as accepts. Comparing reverse cleaner, Throughflow cleaner, and gyro cleaner, where all the cleaners are used in removing low density contaminants, see that feed consistencies, all the cleaners should be between 0.5 and 1%. Even though you can operate this gyro cleaner at higher consistency, you will sacrifice contaminant removal efficiency as consistency increases. So lower the consistency, better in terms of contaminant removal efficiency. Pressure drop is in the order of 15 to 20 psi in Throughflow cleaner, somewhat higher in gyro cleaner and reverse cleaner. Reject rate, as we saw earlier, is very high in reverse cleaner, but relatively low in Throughflow cleaner and quite low in the case of gyro cleaner. Volumetric flow rate of the feed through reverse cleaner can be of the order of 15 to 30 gallons per minute, 25 to 40 for Throughflow cleaner, whereas very high 2800 in gyro cleaner. So because of the high flow rate and low reject rate, you do not need secondary stage in gyro cleaner, and also you need only few gyro cleaners as opposed to 50 or couple of hundreds of Throughflow cleaner and reverse cleaners. Retention time is relatively short in the Hydrocyclone as opposed to gyro cleaner, and also the amount of centrifugal force you generate in reverse cleaner and Throughflow cleaner is very limited compared to gyro cleaner, where it is 700 times the gravitational force. In summary, many different types of cleaners are available depending on the type of contaminants we want to remove. Forward cleaners are used to remove contaminants with density greater than that of water, and different diameter cleaners are available to remove different size contaminants. So large diameter forward cleaners are used to remove nuts, bolts, and paper clips, whereas small diameter forward cleaners are used to remove fine contaminants like sands and ink particles. Many types of cleaners are available to remove contaminants with density less than that of water, reverse cleaners, Throughflow cleaners, and gyro cleaners. And then there are cleaners which can remove both high density and low density contaminants in a single unit, and they are called the core bleed cleaners. That concludes the presentation of hydrocyclones.